down every little word. I'll slow down when we get to the real calculating things. So we're going to talk about frequency distributions tonight is the first thing, and then we're going to go over histograms. These are basically ways of organizing data. So this chapter, chapter 2, is all about how do you display a bunch of data in a way that's meaningful for people. Do you know what I mean by that? How do you have a bunch of scores be meaningful? So, like for example, if I was to, if after our first exam is over, if you guys were to ask me, hey, Mr. Heron, how do we do on our first exam? How'd the class do as a whole? I know how I did. I got my score back. But how'd the class do as a whole? Well, how could I tell you how the class did as a whole? Could I just read all the scores? 85, 76, 69, 93, 48, 72. If I was just to read all those numbers, that would be virtually meaningless, wouldn't it? That wouldn't give you any feel for how you did as a whole. You tracking with me? So to know how you do as a whole, you got to have some kind of picture. That's how our minds work, right? A picture worth 1,000 words, as they say. So that's what we're talking about here. Frequency distribution is one good way to do that. You don't need all those little words. I'll show you what matters as we get to it. So here's an example. We'll slow down right here. McDonald's lunch service time. So using the McDonald's lunch service times in the first table, follow the procedure shown in the next slide to construct the frequency distribution. So there they've got a frequency. So if you wanted to take all this information, if your job is to take McDonald's, whatever it is, lunch service times, and organize them and report to the boss and to the board and the decision makers for McDonald's how they're doing on their service times, how would you give that information to somebody in a way that's meaningful? You tracking with me? Here's the real use, one of the real uses of statistics. Suppose you have all the different McDonald's stores. There's executives that do exactly this, right? And people that report to those executives this information. Are you tracking with this? This is virtually, or very similar to the job my son just got with his math degree from Fresno State. He just got a job where he's going to be reporting to a company, to the president. He's going to be telling them what their products are doing. Which products are making money, how much money they're making. He's going to be giving the information to the boss, who will then make decisions based upon that information. So it's a lot of people in real life, this is their job, things like this. So how would you take all these times, if it was your job to take all the information from a whole bunch of different McDonald's stores, you're working in the corporate office, you get information from a bunch of different McDonald's stores on how long it takes them to crank out their lunch service times, how are you going to display all this information to the decision makers in a way that will help them make decisions? Well, one good way is a frequency table. So this right here is a frequency table. Make sense what's happening there? We're just saying, all right, how many of these are between 75 and 124 seconds? What is that? That's a minute, a little over a minute to 2 minutes. About 1 to 2 minutes, right? 11. So that means 11 of these boxes up here are in the range 75 to 124. How many between 125 to 174, etc. So that's a frequency table. See how this information is a summary of all of that. But see how much better our minds deal with this than they do with that? Right? If you needed to make a decision, hey, are our McDonald's lunch times, are they serving customers in under 3 minutes? What would you say? Are they usually serving customers in under 3 minutes? How much time would 3 minutes be? 180 seconds, right? Let me grab my pen here. Yeah. So I'm just giving you, for instance, on something, a decision maker. So 3 minutes, times 60 seconds every minute, that'd be 180 seconds. So any service times under 180 seconds would be under 3 minutes. And so how many service times are under 180 seconds? About. 35. Yeah, but what are these two right here? 11 and 24, add them up, 35. So 35, is that the majority? Yeah, certainly. There's only, 15 that are higher than that, huh? So the great majority are under 3 minutes. I'm just making up the 3 minutes. I don't know, what their goal would be, what the decision maker would want. But you see how this information is a good way to summarize all of this data. So that's what we're looking at in chapter 2. It's how do you take a whole bunch of numbers and make something meaningful out of it? This is what people need to do in the real world who make decisions. All right, so that's called a frequency. So again, this is called a frequency chart. Was that what they call it? I'm just going to call it a table. Frequency table, frequency chart. Let's take a look. So now, how did they make that up? Honestly, I don't care about all this. Blah, 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 blah. I'm a funny teacher that way. But really, you're not. They give all these little steps. Select. It's all right. You can read through it if you want to. Who cares? You just make the classes however you want. They're being really specific about making them up in certain gaps. That would really vary depending on what you really cared about. So I'm not going to, that's not important. That really doesn't matter. They went through I'm going to skip through all that. So in the end, this is our frequency chart. So they broke it into nice little, it is nice to break them into even seconds. If you subtract these are all right about 50 seconds, I think, aren't they? Isn't the gap of each of these 50 seconds? They basically said subtract the highest minus the lowest and divide by how many groups. It doesn't matter. You're not going to be required to do something like that. Just in the end, do you know what that frequency chart means? Is that making sense? And can you put one of those together? I don't care about all those other details. That's not really super important. So let's change the game now. Now we're going to talk about a cumulative. And we'll get to the homework, right? You know how I do this, right? I go through lecture, and then we actually do your homework. So you'll see what I mean. When we get to the actual homework, those other steps won't matter. There's nothing in the homework that you need those steps for. All right. Cumulative. What does it mean when somebody says cumulative? What does that mean in front of a word? If something accumulates, what does it do? Builds up, adds up. Yeah. So a cumulative frequency distribution is one where you add them up as you go. Let me show you what I mean. If you take, so the first category was 11, right? 11 times they served the lunch between 75 and 124 seconds. 24 times, frequency, how many times? They served the lunch between 125 and 174, right? Now what they're going to do is they're going to add those two up, which we already said is 35, right? 11 and 24 is 35. See how they have a 35 right here now? They added those up. So now what they're doing is they're adding up their categories. They're saying, okay, how many are less than 125? How many are less than 175? That's the first two categories added up. You tracking with me? And then it just keeps going. So see how they're saying less than 25, less than 15, less than 125. So they're basically taking these categories. If you say less than 175, here's 175. So less than 175 is both these combined, isn't it? And that's what they did. That's how they came up with the 35. So that's just another way to display information. It's cumulative. They're building as they go. Until the end, they have all 50 of them. So that's another way. So that way it'd be real quick if you want to say, hey, how many are 175 or less? It's just right there for you, isn't it? 35. And what percentage is that? How about if we wanted to answer that super quick? What percentage of all the lunch service times were 175 seconds or less? What percentage? How would we find that?
You add them all together and divide by less than 75?
Right. So you always, for percentage, it's always the number over the total. What's the total number of them? So how many total numbers are here? What is it? Yeah, it's the 50. Remember, this is a cumulative table. So the bottom line's got to be the total, doesn't it? So there's 50 numbers total. And how many are less than 175? Yeah, it's directly telling us 35. Divide those in your calculator, 70%. We good? See how quick that table is to give us that information? Yeah.
I have a question. Are we going to be able to get like a sheet or something to be able to write down the formulas? Like I noticed that you had a formula in the very beginning.
Yeah, you get a 3x5 card. Have I not said that? Yeah, good question. 3x5 card. Write anything you want, front and back of a 3x5 card for each exam. Yeah, so put down whatever formulas you want. on that as we're going.
Oh yeah, you said, yeah, that's right, it's on YouTube, right?
Yeah, I've already looked at his.
What's that?
Your YouTube channel for his class, I've already looked at it. Pretty cool.
Oh yeah, right. These lectures are out on YouTube. Yeah.
Yeah.
So you can watch it later, yeah. So, but yeah, and I'll give you a practice exam before the real exam, and then as we go over the practice exam, I'll say, hey, there'd be a good thing to put in your 3x5 card. There's a formula we're using. You know, that'd be the time when we'll really summarize things.
Okay, because I just saw that you just skipped the formula, and I was just like trying to write it down, but you didn't.
Oh yeah, especially when we get to the homework. Don't worry about it too much. As we get to the actual homework problems, then we'll see exactly what formulas we need. Yeah, I kind of skip around on some of the lecture stuff, but we'll get to the homework. I'll show you.
Thank you.
All right, so I'm just kind of making up some things. Till we get to the actual homework, it's pretty casual. So critical thinking, using frequency distributions to understand data. So in statistics, we're often interested in determining whether data have a normal distribution. You heard of that before? The normal distribution? Normal distribution. They start low, increase, then decrease. So do they have a picture for us? No? All right, we'll get to a picture in a little bit. So, well, I'm going to give you a picture right away. It's basically, anybody know, normal distribution looks like what?
Up and down.
Anybody ever seen it before, heard about it? It's a bell curve. So we'll get really, I mean, we're going to spend half this class talking about it. So we'll get there. You'll know it like you know the back of your hand by the time the weather's warm. You will know the bell curve quite well. But this is our first experience. Normal distribution is a bell-shaped curve. I know that probably doesn't mean a lot yet. Hold on, we'll see. Just kind of getting your feet wet at this point. We'll see. We'll dive in a little bit more seriously later. But for now, normal distribution. Look, that's probably kind of meaningless. Like, what if we were to say, let's just pick something at random. How about men's shoe sizes? If you were to measure men's shoe sizes, there would be some average, right? I don't know what the average man's shoe size is. 9, 10, I don't know, whatever it is. Let's just say it's 9. So there'd be some average shoe size. And then there'd be people that have bigger feet, 10, 11, 12. There'd be people that have smaller feet, 8, 7, 6. And there'd be some people that have really, really big feet. I don't know, what's the biggest shoe size? Like 18 or something? And there'd be some people that have super small feet, like size 3 or something. But there wouldn't be a lot of those, would there? That's the bell curve idea. There's a whole bunch of people that are average in the middle, and then there's just a few people that have really, really big feet or really, really small feet. That kind of bell curve. Most people are in the middle. Most people are average, so it's higher in the middle. And when you get really tiny or really big or really tiny, there's fewer. We find that comes up all the time in real life. Almost everything that occurs naturally. Shoe size, earlobe size, number of leaves on oak trees, almost any size of a snail's shell. If you were to go out like a scientist and grab 1,000 snails out there in the grass and say, I'm going to weigh them all. How about we just do the weight? I'm going to weigh 1,000 snails' shells and see what the average shell weight is for snails. You know what you would find? If you put them on a graph, you'd find some average weight. I have no idea what the average weight is. And you would find most snails are right around the average. A few of the snails have really big shells. A few have really small. You would find a bell curve. So that's what we mean by the bell curve. Get the idea? Anything that occurs naturally occurs in a bell shape. Most in the middle, a few really tiny, a few really big. We call that normal distribution because it's normal. It's what you normally find. It's normal distribution. We're going to use that a ton in this class. So that's just kind of the beginning idea. Gaps. Whatever. Let's skip that. That's not that important. All right. Let's talk about exploring data. What does a gap tell us? Oh, I don't care about that. Sorry. I'm skipping over that. I don't care about that at all. Comparisons. Combining 2 or more relative frequencies in one table makes comparisons. Yeah, whatever. All right. Example, comparing McDonald's and Dunkin' Donuts. All right, so here we go. So we're going to compare, we've been talking about the McDonald's, we figured out what percentage they serve between 75 and 124 and all the different percentages. How does that compare to Dunkin' Donuts? Well, so we put them in the same table. So this is another way to display data, to kind of compare. Who's serving their customers faster? Looks like a little bit Dunkin'. Of course, I think they might have less to do. But anyway, so we're measuring. So it's just a way to compare two things, is to put them in side-by-side charts like that. I think that's probably pretty easy and obvious for you. So there we go. Same information. So, and there can be explanations, whatever. I'm going to move on. And that's it. To the homework we go. All right. So I'm going to dive into the actual homework. So here's where I'll slow down and show you what we're talking about. So refer to the table summarizing service times of dinners at a fast food restaurant. How many individuals are included in the summary? Is it possible to identify the exact values of all the original service times? So let's answer the questions one at a time. So let me make this a little bigger so you can all see it. And I'll copy it over. Here we go. Here's where I'd encourage you to probably take a little bit more careful notes. Here's question number 1. And so I'm doing your homework with you now, like usual. Here's question number 1. Can y'all see that? It's kind of small, huh? I thought I made it bigger. Well, it's just tiny in that projector. Number 1. So they're giving us this frequency chart. There we go. They're giving us that frequency chart. And they're asking us, what are they asking us? The questions are off the screen now. Oh, how many? How many in this study?
49.
Yeah, just got to add them up, huh? So it's easy enough. Just add them all up. Use your calculator. So is that what it is? 49? I'll take your word for it. 21. 49. All right, so 40. So the first question is, how many in the study? 49 in the study. Just add up the numbers. Frequency means how many. Are we good to there? So I'm going to slow down a little bit and make sure. So this is the actual homework now. I fly over the lecture part. But here's the actual homework. We'll make sure this is clear for you. Frequency, what everybody good with what this means? This means 8 times they served the meal between 60 and 119 seconds. And 20 times, that's frequency, between 120 and 179 seconds, etc. Good? Making sense out of that table? So how many entries in this table? Just add these up. 49 pieces of information are in that table. All right. Can you read those words? Is it possible, so we're still on number 1, this is the second part of number 1. Is it possible to identify the exact values of all the original service times? Yeah, no is the answer. Does everybody see what I'm talking about? Look back here. All I know is 8 times they were somewhere between 60 and 119. I don't know if they were 60, 61, 103. I don't know. I can't tell. Just want to make sure we're clear on what it tells us and what it doesn't. All right, so no, the frequency distribution tells nothing about the data values that fall between the lowest and the highest. What's the other no? So this is the right one. What?
That's it, wrong.
Oh, is that wrong? No tells us, what's the data values in each class could take on any value. Oh, what's wrong with that? Yeah, that sounds even better. It's always good to read all the options on a multiple choice test. I was just trying to show you. I really knew. All right. What is wrong with A? A sounds pretty good to me. Let's see. What's wrong with A? The frequency distribution tells nothing about the data values that fall below the lowest or above the highest. Oh, yeah, no, that's good. I just read it too quick. That's not correct. It tells, we don't, data values that fall below the lowest, that'd be like below 60. There's no data values that fall below 60. Or above the highest, above 359, there's no values that do that. They're just being stupid. That has nothing to do with it. I just read it too quickly. Yeah, be careful on the test, huh? These can trick you. Which is what I was trying to show you. They're tricky. All right, so let's move on. We good there? So what? They want us to go from frequencies to percentages. How are we going to do that?
Add them up.
Yeah, got to start by adding them up, right? Add all these up. So let's do that. Let's add all these up. What is that? Is it 40? I think. I did it quick. Is it 50? I need your help here. It's 40. It is 40. I did it again. It's 40. We good? So it just adds up to 40. So now, how do I use that to turn it into a percentage?
Divide by the frequency.
By each frequency.
Yeah, each one. Good. We good with that? You guys are right on the money. So 4 divided by 40 is 10%. It comes out 0.10, and then you change it into a decimal. I'm sorry, you change it from a decimal to a percentage. It moves 2 places. We good there? Next one. 12 out of 40. What's that one? I got my calculator here too. Oh yeah, I wanted to remind you guys, are you guys ordering the TIs? 83, 84. We'll use those in about a week or two. We're going to start using those. It might be next week. I think it is. Double check. Yeah. Next week we will use this. So I encourage you. Don't have to have it. I'll show you a longer way to do it without it. But it's super convenient. It'll start being really helpful to you. So I'd encourage you to go on Amazon. Just buy a used one. Remember, don't get $100. Don't waste your money. Just get an old $40, $50 one off Amazon. Remember, I went on for you. Did I go on? Oh, I didn't show you. But if you go on Amazon, type in TI 8384. You'll see the used options between $40 and $50. You can get a used one. And we'll start using them next week. I'll show you how to do special things to make the problems way easier. We'll have these long homework problems that have like 10 or 15 data numbers. And there's a way just to type it in one list, hit the button, it calculates everything for you for the homework we'll do next week. Things get a little more complex next week, so it'll be super helpful for you starting next week if you can grab it. All right, so 12 out of 40. Somebody got those numbers for me? I'm getting, 30%, huh? 0.30, so it makes 30%? Yeah.
Here it's telling you
Eddie.
divide the frequency and category divided by total frequency times 100%.
Yeah, that's their way of saying move the decimal twice. When they go times 100, that's what makes it go from 0.30 to plain 30. Yeah, see the decimals move, boom, boom, right to there. Yeah, good clarification.
42.5.
Is that the next one? So 17 out of 40, 42.5%. 6 out of 40, 15%. And 1 out of 40, 2.5%. Is that good? Just dividing each of them by 40, and then, move the decimal 2 places to the right. You guys know that when you change the percentage. That's all they're saying with that times 100 thing. Yeah, they'll do that throughout the whole course. They'll say times the 100, but they're just saying move the decimal twice. Right? When you multiply by 100, it moves twice. Good so far. So this is your exact homework, as you know. That'll be number 2, different numbers, but same thing for you all. That's your number 2. So we're doing your homework right now. So what are they saying on this problem? So I read those words quickly. Let me slow down and explain again. This is heights of males in centimeters. So they're giving different categories, like how tall different males are. And they're saying these are the percentages. And they said, if you read all those words, which I read super quickly, they said the heights are normally distributed. Now remember what that means. What is normally distributed? We're going to be using that word all semester long. Bell curve. Yeah, humped in the middle, meaning most people are average. Very few are really tall or really short. Most people are more in the middle, right? It's just a big pile in the middle. It's a bell curve, normal distribution. Okay. So they're saying there's 2 problems with these numbers that really don't fit a bell curve. Do you see a couple of those numbers or a couple of issues there that for sure don't fit a bell curve? So bell curve is supposed to be highest in the middle, biggest percentage in the middle. Is it?
No.
Here's the middle. Is that the biggest?
No.
So that's just something's wrong, right? That data, I don't know what this researcher did, but that just can't be reliable data. We would doubt that the researcher did a good job on this one because heights are normally distributed. Somehow this researcher went out and found that the lowest percentage was the average people and the middle heights. That's just not reasonable. Unless he just went to a basketball game or something. I don't know what he did. But he didn't survey average people, in other words. Is that making sense? That doesn't fit. You should, the middle, let me be more clear and just write out what I'm saying. The middle should be the biggest percent, shouldn't it? The middle should be the biggest, and the ends should be smallest. Right? The middle should be the biggest, and the ends should be the smallest. That's what the bell curve says. It's small percentage for, really tall people, really short people. There's not a lot of people that are like 6'9" and bigger. There's a lot of people that are right around, 5'10" to 6 foot probably. So, right, is that making sense on that? So this data is looking pretty bogus because the biggest percentage, almost the biggest, is at the end. And the middle has a small percentage. That's not fitting. Let's go look at the words, though. I don't know exactly what the words say. I'm just giving you an idea as we look at it. Let me get the words up. Okay, so let's read them through. And let's read them all this time so we don't mess up like we did on the other one. A. The classes do not allow for the possibility that an adult male could be less than 130. I don't know, that's kind of dumb. Classes do not allow for the possibility adult male could be, whatever. The relative frequencies are recorded as percentage, whatever. All other relative frequencies appear to be roughly the same. That's true, they kind of do, huh? They're pretty close. If they are from a normal distribution, they should start low, reach a max, then decrease. Yeah, D's looking good. Now I'll read on. Because I messed up before. But D's sure looking good, right? Let's read on. All the relative frequencies are different. Well, yeah, they should be. If they are from a normal distribution, they should all be the same? No. No, it's a bell curve. It's not a level curve. They're not all the same. The sum of the relative frequencies is 125. Oh, is it?
Yes.
Oh, I didn't even look for that.
It asks for 2 things.
Oh, yeah, it asked for more than one right answer here, huh? Yeah, good. Okay, so let's go back. I didn't realize that. I didn't even try to add them up. So they added to 125?
Yeah.
That's some bad research. So I guess if you add these up, they're 120. So that person did a bad job. All right, good. We good with that then? Making sense?
So, it says select all that apply.
Yeah, I didn't notice that either.
Well, I noticed it asks for two things that are wrong.
Yeah, right. So that's how we do it. Yeah, right. Exactly. All right. Number 4. Oh, before I forget, remember, we're giving extra credit for those who go to see Brian and Brian, we have your times down, don't we? Did I write those up last time?
Yeah.
Is that what I did, or want to put them up?
But you have my flyer?
Do I?
Yeah, remember I said just post it up on Canvas for him? So if they open up the page, it's right there.
Oh, you mean you sent it to me? It's on my email or something?
I emailed it to you.
Oh, okay. Do you know them off the top of your head?
Yeah, it's Monday, Wednesday, 5 to 5:30.
Monday, Wednesday, 5 to 5:30. Yeah, I'll try to remember to post that. Monday, Wednesday. So those are what do they call them? ACE?
They're in ACE and which is room 459 in the library.
Oh, ACE 459 in the library.
Oh,
Brian, are you spelled with a Y or an I?
oh no, I-A-N.
All right. So remember the extra credit offer on the thing. Yeah, Brian.
Justin said you put it in the announcements.
Oh, I did.
Or did I? Did he?
Somehow it came across, huh? You saw it on something. Okay, good. Yeah, I just want to remind you. So remember, I gave you the SI session extra credit game plan at the end. Basically, if you make it to 9 or more, I'll take your lowest score and bump it up to 90, etc. So that's on the syllabus. Remember that. I just want to remind you that as we're going. All right. So looking at number 4 here. What do you think? Does that look like bell-shaped data?
Yes.
Yeah, it kind of does, huh? Why are you saying that? Why do you guys think that does?
1, 3, 7, 12, 7, 4, 1.
Yeah. Starts low, goes high, goes back low, huh? See how that looks like bell-shaped data? Right? We're, bell curve. Starts low, then gets higher in the middle, like 12 in the middle. Here it's only 1, then 3, then 7, and then it starts going down. 7, 4, and then real tiny 1. Yeah. So it's like a bell curve, huh? Starts low, gets high, goes back to low. So that's looking like bell-curved data. Okay, so here's question 4. Here's the option. So it's going to be one of these yeses. Let's read the first one. Because the frequencies start low, proceed to 1 or 2 high, then increase to a maximum? No. Let's try C, right? So that's wrong. They don't increase to a maximum at the end. That's not right. Because the frequencies start low, then decrease to a low at the end. And it's symmetric, yeah. It is symmetric. You know what I mean by symmetric? Right? The symmetry means it's the same on the right and the left. So, yeah. So, answer C there. We good on these? So far, so good. So, number 5. They want us to take this data and put it into a frequency chart. So, let's do it. So, you just got to be careful how the system just cross things out as you go. So, those are all on the screen there for you. Okay. So here we go. See the different categories? Let's start with the 17.7. Which category is that in? First one. So I'm just going to do like a tally mark. 1. And then next one, 29.8. You could go across or down, doesn't matter. Which category? Where's that one? It's the third one. Right? 19.2. Right there. 27.4. That one. Etc. We good with that? Just keep going. Just keep marking them off. Want me to do them here? I'll crank them through. 33.5. That's going to be over here. I'll do this one. 25.8. That's in the middle, isn't it? 25.7. That's here. Just be careful. 44.9. That's in the last one. 26.4. That's here. 18.3. That's here. 23.1. 30.7 is here. 25.7. That's 5. You can do it however. I'm just going to do like, what's that called where you do those marks and you cancel them? It's tally marks, I guess. Tallying them. 29.6. 4. 37.7 here. 25.6. That's the middle. 23.1. That's the middle. 24.6. Middle. 30.4. It's down here. 22.8. That's the middle. Okay, so that's all of them. So what did we get? We got 3 here, 9 here, 5 here, 2 here, and 1 here. Brian.
I know they can't use it on tests, but on the homework,
Yeah.
there's a question help,
Yeah.
okay? But next to that set of data, there's that little blue box.
Okay.
Click that, open in StatCrunch, and they can sort it from lowest to highest.
Oh, that might be nice. Okay.
No, just go to your,
We good? So that would make it easier. That would put them in order, make it easier to do your categories.
yeah,
But-
because it's really simple when you're doing the tally method like you were.
Yeah.
To miss one.
Yeah, totally.
I was like,
That good? Does that make sense? So I just put them in order and then just draw the line according to these breaks in the categories. And then that tells me how many for each category. All right, you guys are like, we got it, Mr. Herron, move along. All right. All right, good. All right, so here we go. So let's do it now. We got all the information. So there's what they want us to do. They want us to find out how many actors were in their 20s, 30s, 40s, 50s, etc. And so here's the data set they gave us, all those numbers, which you could just do by hand. But there it is, having been organized by StatCrunch. So how many in their 20s? 1. Easy to see, huh? How many in their 30s? It would be down to here, huh? So that's 12. Take away 1. Must be 11 in that category, huh? See how easy that is? And then how many in their 40s? Looks like it goes all the way down to here. Goes down to 25. Take away 12. There must be 13 in that category, huh? See how I'm doing that really quickly? So save hours of your life. Brian's saving hours of your life.
It just saves headaches of you missing a number, going back.
What happened? I did the whole problem. And it's hot. Math Excel is harassing me. Tell me I'm wrong. Yeah. Everybody see how much easier this is? So once you sort the data, They want to know how many in the 20s, that's just 1. See how I got this 11 here? I just took 12 minus 1. Right? And then you want to do the next category, the 40s. I just took 25 minus the 12. 13 must be in this category. Right? And then in the 50s, is it that? I can't see the very bottom of that. Oh yeah, no, that's it. Okay. In the 50s, my mind goes off the screen, but you get the idea. What is it, 3, 4, 5 of them in that category, etc. So we'll bring those back, 1, 11, 13, 15. So we'd say 1 is here, 11, 13, 15. I can't tell. How many in the 60s? Oh, I'm looking at is that the wrong data? Where did I go? There. Can you guys tell?
Scroll down.
2 in the 60s, 2 in the 70s.
2 in the 60s, 2 in the 70s?
Yeah.
Is there more though?
Scroll down.
Yeah, I can't. The way it's on Doceri now, so it's not
Oh.
scrollable. Here, yeah. So that was right. So we got this data correct. There were 2 in the 60s, 2 in the 70s. So coming back here, then. Now they want percentages, or no? They just want number of actors. So that's it. We're done. Yeah. So that stack crunch thing is nice. Everybody tracking with how to do that? So that's on the board. If you want to write that down, the steps for getting stack crunch into action for you. All right, I'll keep moving. So here's question number 8. Right there, so question number 8. So basically it says start at 123.9, which they did, and it's off the screen now, but go up 0.2 each time. They said make each category have a 0.2 width. That's off the screen a little bit. 0.2 width. So if I'm starting at 123.9, and I add 0.2, what's that going to be? 124.1 on that one? No, what's up, Ryan?
So the class width, 0.2, you would add to 23.9, that would be the lower of the next class.
Oh, yeah, you're right. Thank you, Brian. I'm messing up. Brian should be teaching this class. 124.1. Yeah, that's the beginning of the next class. Thank you. Right? Yeah, so that's what you do with your 0.2, is you add it straight down. Very good. And then we just keep going with it. So you add your 0.2. That's going to be the, well, what do they want me to put there for the 124?
Okay, so 123.9 to 124.0.
Okay, so it'll be right below. Yeah, so let's just first get these like Brian was saying, and then we'll go back and fill in the others. Just keep adding 0.2. 124.3, 124.5, 124.7. We good? Just keep adding 0.2 on down. Yeah, and then we'll fill in the other things like Brian was saying. But are we good so far? Is this making sense? They're saying the class widths are 0.2. So I'm just adding 0.2 to get to the beginning of each of the next classes. And then how I find the end of the classes is I back up right before that. So if this one's going to begin at 124.1, this must end at 124.0. Make sense? If the next one's going to begin at 124.3, this must end at 124.2. See how we're coming up with that? Etc. This ends at 124.5, so begins at there, so this will end at 124.4. This one begins at 124.7, this will 124.6. And see, these are just going up by 0.2 every time also, huh? So this will be 124.8, won't it? On that, Brian.
So why it's done like this is if you just added 0.2 to 123.9, made that your upper.
Yeah, that's different than...
Right, because then that's a class width of...
yes, you're right.
But actually, the class width is 0.2, so if you had a value of 123.9, that wouldn't be in there. You'd be losing that, is what I'm saying, is like...
They're not including the endpoints here?
No, they are, but okay, let's say you have, your lower class is 60, and the class width is 7. So what do you think the upper should be?
So it'd be 66 is what you're saying.
Right,
Yeah.
you have to count
Right.
60.
All right, exactly. So understand what Brian's saying there? He's right. So this is a funny, it's probably a weird math teacher. Life's simple. I don't want to be confusing for you. Just whenever they tell you, when they give you a class width, like they are on this problem, just add it to the left edges all the way down and then figure the right edges afterwards. Make sense? That'll work perfect for you, because that's actually class width from here to here, is what Brian and I are pointing out. So that's class width. Good. Okay, so now let's go do the frequencies.
Results should have normal distribution, so you have to find out if it's a.
Normal, low, high, low, or not. Yeah. But everybody good? Now that we have the categories, you could do the rest, right? Now that we've made the categories. So everybody again, one more time. So I think, sorry, that wasn't very clear on my behalf. Make it clear. Whenever they give you a width, 0.2, just add it to the left edge first. 0.2, 0.2, 0.2, 0.2, and then figure the right edges afterwards. And then just put them in. All the data is given to you down there. Just put it in and answer the rest of the questions. So basically on this problem, this is problem number 10, I'm going from a normal frequency table to a cumulative. Why did the word cumulative go out? Oh, this is question number 10. So how do you go from this normal frequencies to cumulative? I think it'll be pretty easy for you. Here we go. How many actresses were between 20 and 29 years old? Well, less than 30 years old?
27.
No big deal there. Just take that straight over. Now, there were 34 actresses between 30 and 39 years old. So how many less than 40?
61.
Yeah, these two added together, huh? 61. You with me? See how we're accumulating? We're adding them up?
75.
Yeah, the next one, how many less than 50? So you would take all three of these and add them up, right? 27, 34, 14, what's that? 3, 4, 5, 6, 7, 75? 75 are less than 50, etc. We good there? So that's a cumulative. You're adding them up, accumulating them on that. All right, you stop.